Hi there. This video is going to give you an overview of the basic types of chemical reactions that can occur in inorganic chemistry. So please excuse my handwriting. I will try and be as clear as possible. Now, the reason why we categorize chemical reactions is that this will help enable us to figure out the products of the reactions when just given the reactants. So the first type of chemical reaction that we'll look at is called a synthesis reaction. Now you can also call it a combination reaction, whichever you prefer. But based on their names, you can sort of figure out what they look like. You are going to be combining two or more simple, smaller substances to synthesize one more complex substance. So a synthesis reaction in general, you could say A plus B goes to AB. And the key here, is one product. If you see a reaction that has one product, you should think synthesis reaction. Okay, let's do decomposition is our second type of reaction. Decomposition reaction. A decomposition reaction is sort of the opposite of a synthesis reaction. This time you're going to be starting with one more complex substance, and you're going to be breaking it down into two or more simpler substances. So for example, we take AB and turn it into A and B. And the key identifier for a decomposition reaction is one reactant. So if you see one reactant, it is a decomposition reaction. Doesn't matter how many other products, but if there is one reactant, you've got a decomposition reaction. Let's do the third type here. The third type is called single replacement. And as you might guess from its name, you're going to replace or do one replacement, one single replacement. So single replacement is usually a reaction between an element and a compound to form a new element and a new compound. I'm writing it below just because I ran out of space. So let's do this with just generic letters here. So what if you had A as your single element and you combine that with BX? B is the metal in the ionic compound BX. X is the non-metal in the ionic compound BX. And basically, you are just going to switch A and B. So B was in the compound to begin with. So now it is going to be the free element. And A was the free element, so it's going to be in the compound. So all you really did was A and B, one single set of elements, switched or got replaced by one another. Single replacement. So the next one actually looks, so it sort of has a similar name to single replacement. This time it's going to be a double replacement. Double replacement reaction, instead of just one set of elements being switched, is going to be two sets of elements being switched. So you're going to start with a compound and another compound, and you're going to make a third different compound and a fourth different compound. So let's use our generic letters. So let's say I have AX and BY as my two reactants. The A and the B will switch places, and the X and the Y will switch places. So I'm going to now have BX and AY. it's kind of a partner swap, right? A and B switched, and A combined with Y, and X and Y switched, and B combined with X. It's always going to kind of look like this with the outside ones coming together and the inside ones coming together when, because it's going to involve ionic compounds. Now, our final type, basic type in organic chemical reaction is a combustion reaction. And I hope you've heard of combustion before. Most people think burning. And when you think burning and what substance going to help something burn, you should think oxygen. So when oxygen is one of the reactants, you have a combustion reaction. For example, the most common type of combustion reaction is when you have a hydrocarbon reacting with oxygen. A hydrocarbon is just like it sounds. It's something that contains hydrogen and carbon. The carbon's always written first. And these X and Y down here can be any numbers, any subscripts. And when you burn a hydrocarbon, when you react oxygen with a hydrocarbon, you're always going to get the same products. So it's pretty simple. You're always going to get CO2 and water. Always, always, always. But the key here to indicate that it was combustion was the fact that you saw O2 on the left side of the arrow in the equation. Combustions can also be categorized, some combustions can also be categorized as synthesis reactions. For example, if you had Mg and O2, and you see it makes MgO, this is a synthesis reaction. You've got two elements combining to make a more complex product, but it's also combustion because one of your reactants was oxygen. So in summary, we had 5 types of inorganic chemical reaction types. We had synthesis, decomposition, single replacement, double replacement, and combustion. So I hope this will help you in when you're given a whole reaction. This will help you in identifying which of the 5 type of reactions it is.